Hello, welcome to Chapter 3, homework questions 76 through 81. Question 76, on the graph, plot A, B, C, D on graph paper. So let's go ahead and do that. So now that we have it graphed, part A, rotate A, B, C, D 90 degrees clockwise about the origin to form the new figure A prime, B prime, C prime, and D prime. Name the coordinates of B prime. So using tracing paper right now would be a good idea. Alright, now that we've done that, B prime is ordered pair, looks to be, let's see what we got, 5, comma, negative 2. Alright, on B we want to translate the new figure up 8 units and left 7 units to form our new one, and then name the coordinates of C double prime. And the coordinates for C double prime would be at negative 4, positive 2. And then on part C, after rotating A, B, C, D 180 degrees to form your new A double prime and so on, notice that A triple prime position and orientation was the same as the original A, B, C, D. What was the point of rotation and how did you find it? So I'm going to use my other graph here, our coordinate plane, to do that. And so as I was looking at this problem, Aaron noticed that the position and orientation was the same. So when I originally did this, you can see right here that I actually rotated it around the origin, but it didn't say that. It said that the position and orientation was the same. So basically it fell right on top of the original. So I had to go back and rethink about this. And by rotating it around the point kind of in the middle there, at the point 3, I was able to get point C rotated to be point A, and point B and D changed positions as well. And so therefore I was able to find out that the point the point of rotation was in the middle, which was at 3. And another way you can look at it is if you make the diagonals, it intersects right there in the middle as well. So this one really doesn't need to be there, but I was just kind of showing you originally what I was thinking and why I got that shape over there, and maybe why potentially you did as well, is because originally these figures over on this one was asking us to rotate around the origin, but on part C it doesn't say anything, it just says the position and orientation must be the same. So I originally made the mistake of rotating around the origin and then realizing that the position, the orientation was okay, but the position was not exact, so I had to go back and fix that. Question 77, examine the graph of lines CM below. Find the equation. So to find the equation, we need the y-intercept, which looks to be at 0, 2, and we need the slope. So we have 2 and 4. So we can write the equation as y equals 2 over 4, or 1/2 x plus 2. Find the perimeter and the area. So the perimeter, we have 2 and 4, but we need to use Pythagorean theorem to find out what the hypotenuse is. So 2 squared plus 4 squared is equal to the distance of CM squared. So we got 4 plus 16 is 20. And then we can take the square root of both sides and get that the distance is the square root of 20, which we can figure out approximately what that is so we can get a better idea as to what the perimeter is to the nearest tenth. So 4.5 is approximately, so let me change that equal sign to approximately 4.5. So therefore the perimeter is 2 plus 4 plus approximately 4.5, so the perimeter is approximately 10.5 units. We also need to find the area. We have enough information there. That's half the base times the height. So that is exactly, for this one, 4 units squared. Write an equation on the line through point M that is perpendicular to CM. So our slope for CM was 1/2. So the perpendicular slope is opposite reciprocal, which is negative 2 over 1, or just negative 2. So we have our slope. It wants to go through the point M, which is located at 2, 3. So we can find our y-intercept by plugging in the information we know. 3 is equal to negative 2 times 2 plus b. And we can calculate b to be 7. So therefore our equation that is perpendicular is y equals negative 2x plus 7. Question 78. Use the relationships in each diagram below to solve for x. Justify your solution by stating which geometry relationship you used. So we know that these two lines are parallel. So if the two lines are parallel, then we know that the alternate interior angles are congruent. So this has to be 58 degrees. And now we can use our triangle angle sum theorem. 71 degrees plus 58 degrees plus x should equal 180 degrees. So we have 129 degrees plus x is equal to 180 degrees. Subtract 129, and that will give us 51 degrees. So we know x is 51 degrees, and we used alternate interior and triangle angle sum theorem. Part B, a couple different things going on. We do see the 90-degree angle. We don't have any parallel lines. It also doesn't appear we have any vertical angles. We don't have any lines crossing each other exactly. But we do know that a full rotation around is 360 degrees. So can we say x plus 84 degrees plus 3x plus 14 degrees plus the 90 degrees is equal to 360 and solve that. So combine our like terms. That's 4x plus, I think, 188 degrees. Subtract 188 degrees to 360, you get 172. And then divide by 4, and x is equal to 43 degrees, and that's what we're solving for. And we know that because we know the circle has that interior of 360 degrees. And part C, so it's a right angle, so we should be able to use Pythagorean theorem and say x squared plus the square root of 3 squared should equal 2 squared. When you square a square root, they're inverses, they undo each other, so that's just plus 3 is equal to 4. Subtract 3, we get x squared is equal to 1. Take the square root, and you get x equals technically negative 1 or 1, but since it is a distance, we're not going to get a negative 1 distance. X is equal to 1, and we use the Pythagorean theorem to figure this one out. And so once again, make sure you solve, but also make sure you justify your solution by stating which geometrical relationship you are using. Question 79. Congratulations, you are going to be a contestant on a new game show with a chance to win some money. You will spin the 2 spinners below to see how much money you will win. Test your ideas creating the situation below using the double spinner tool, if you have access to it. Part A, make a tree diagram of all the possible outcomes of spinning the 2 spinners. At the ends of the branches on the far right, write the amount you would win for each combination of spins. Alright, so there's the tree diagram below, and make sure you include the dollar amount as it says in terms of winning. On part B, are each of the outcomes in the sample space equally likely? And since you're going to spin, that's all of those are the same size. Same thing on this one, these are both half. So yes, they are equally likely to occur. What is the probability that you will take home $200? What is the probability that you will take home more than $500? So 200, there's 6 outcomes, and to get 200, there's only one possibility there. So that means it's only 1 out of 6. On the next part, to bring home more than, so anything above 500, so 600, 3,000, or 1,500, looks to be 3 out of 6 possibility, which could be 50% or half. On part D, what is the probability that you will double your winnings? Does the probability that you will double your winnings depend on the result of the first spinner? So the probability of doubling your winnings, once you spin and you get the first dollar amount, you're either going to double or you're going to keep it. So that's going to be half that you will double your winnings. Does it depend on the first spinner? And the answer to that is no, because no matter what, you're going to get the opportunity to double your winnings. So the spinners are independent of each other. And then E, what if the amounts of the first spinner were 100, 200, and 1500? What is the probability that you would take home 200? Justify your conclusion. So now, if it's 100, 200, and 15, if you get 100 and you keep, then that would be 100. But if you double, that would give you 200. So that would work. If you spend 200 and keep, that would get you 200. And the 1500 is not going to work either way. So it looks like the probability would be 2 out of 6, or 1/3 probability for that one. Question 80. Solve for the indicated side lengths. Show all your work. So once again, we know the triangles are similar, so let's just match up the corresponding sides. GI is 2. GI matches up with PR. That's divided by N, or over N. And then we want to do GH, which is 7. And that matches up with PQ, which is 112. So 7 over 112. And then we can do our cross multiplying, and then divide by 7. And 224 divided by 7 is 32. So N is equal to 32. On part B, we have XY, and that matches up with AB. So that's M over 7, has to be the same ratio as XZ, is 49 over AC, and that's 23. So 23M is equal to 49 times 7 is 343, and divide that by 23, and we get M is approximately 14, I'll go to the nearest hundredth, 14.91. Question 81. Explain why the shapes below are similar. So you'll notice that this one gives you the perimeter. If this is a rectangle by the perpendicular sides and the 4 right angles, we know this is 9 meters. And if that's 9 meters, then we can figure out what the other 2 lengths are, because the perimeter, we'll just call this W and W. That would be 2W plus 18 is equal to 26. So when you subtract, you get W is equal to 4. So we know both of these side lengths are 4 meters. And then on the other one, if the area is 36 square inches, then that means this must be 9 inches on that side, because 9 times 4 is 36. So now, why are the shapes below similar? Look at their units, so make sure you're paying attention to that. So as you can see, the side lengths are the same in terms of the numbers, but this one's in meters, and this one is in inches. So how can we explain that the shapes are similar? So we know that the corresponding angles are all going to represent 90 degrees. So that's one thing. And then the other thing is the side lengths, even though it's in meters and inches, they still represent the same, the corresponding signs still represent the same ratio. So 4 over 4, 9 over 9, 4 over 4, whatever it might be. Even if you change inches into meters, it's still going to represent that same ratio. So that's why the shapes below will be similar.